Now that we've got a good hand on solving linear equations, we're going to turn to inequalities. So you're going to see this trend in a lot of what we do. We work on the equations, then we go ahead and switch it to the inequalities. So we have a couple things that we're going to cover first. We need to talk about how do I deal with intervals? What does that look like? What kind of forms can I have for intervals? And then once we get familiar with that, we'll talk about how do we solve an inequality. So the one thing you want to make sure you know is that anytime you're dealing with an inequality, your solution is not going to be a single number. It's going to be a set of numbers. So most of the time it's going to be some interval. In the case when we deal with higher variables, so when we start talking about linear inequalities in two variables, you're going to see it's going to be a region that we end up shading. But we need to express our inequalities in a particular way. So we have three main forms. First form is going to be you can plot them on a number line. Second form is you can go ahead and just write the inequality just as is. But the most important one that we want, and we're going to use the most frequently, is known as interval notation. So there's a couple key features. If you want to be able to equal an endpoint, you're going to use one of these square brackets. If you want to say you can get very close to that value, but you can't actually equal it, you're going to use a parenthesis. Now, most of the time, the interval is going to continue on forever in one direction. So it can go all the way to the left to negative infinity, or all the way to the right to positive infinity. Problem is you can never actually equal these numbers. So you're always going to use these parentheses around negative infinity and positive infinity. Okay. So let's get some practice. We're going to go through just a couple different versions of intervals, and we want to ultimately write this in interval notation. So the very first example is going to have a closed circle at -1, and then we're going to be able to continue forever in the right direction. So this means we can actually equal -1. And because of that, our interval, we read it left to right. The very first number that's important is -1, and I can equal it, so I put it in a bracket. And then we continue to the right forever, so we go on to positive infinity, but I can't actually equal that. So that would be our interval in interval notation. If I change it up a bit, and instead of having a closed circle, I have an open one. And now we can continue to the left forever. In this case, our leftmost point continues on forever. So that leftmost quantity is negative infinity. But I can't equal it, so I need to put a parenthesis around it. Then we're going to stop here at 2, but I can't actually equal this number. So what I want to do is I don't want to use 1 as my cutoff. I want to say I can get as close to 2 as I want, because 1.9 is a number that falls into this range, 1.99. So I want to say I can get as close to 2 as possible, but I'm going to use a parenthesis to indicate I can't equal this endpoint. And then for our last example, we're given an actual interval, so I have x can be greater than or equal to 2. So in here, it might be easier to actually plot this on a number line first. So we'll go ahead and put some of our important numbers. -2 is the most important. So we'll go to the left a couple numbers and to the right a couple numbers. And so what this tells me is I can pick all values of x that are greater than or equal to 2, -2. So I can fill in this circle and I can pick all x values that are greater than it as well. So I can continue to the right forever. If this bar wasn't here, that would indicate that I have an open circle. So in interval notation, we start at -2, we can equal it, and then we can take all values to the right. So now that we've got a feel for writing inequalities, we want to talk about how do we actually solve an inequality. And the main goal is honestly exactly the same. You want to isolate the variable. So you want to get x by itself, and we'll end up in a situation like this last one. We can then graph it, and then we can figure out that solution in interval notation. But the one thing you have to remember is that if you end up multiplying or dividing by a negative number, you have to flip the sign. If you don't flip the sign, it's going to be incorrect. So I want to show you why that's the case, and we're going to look at this example. 3 is greater than or equal to -1. I know that's a true statement. 3 is definitely larger than -1. So if I go ahead and I take this equation and I multiply it by a negative number, we'll say -1, the result would be -3 and +1. If I don't change my sign, I don't end up with a statement that's correct. -3 is not bigger than +1. So what I want to do in reality is I still get -3 and +1, but I need to flip the sign to make it a true statement. So make sure you are doing that in your problems. If you end up going through and you get something wrong, this is the first thing you want to check. Did I multiply or divide by a negative number, and did I change that sign with it? So we're going to go through 3 separate examples, and for all of them we're going to do exactly the same thing. We're going to solve the inequality, and then we're going to express that solution in interval notation. So we're going to start with this first one. X plus 3 is greater than or equal to 2x plus 1. So I'm going to do exactly the same thing I did before, get x by itself. So I'm going to start, we have a positive x here and a 2x here. You could subtract the 2x and you'll end up with exactly the same answer, but that leaves me with a negative number over here. So instead, I'm going to bring this x that's by itself to the other side. So we go ahead and subtract x to make them cancel each other out. And that leaves us with 3. We keep our symbol because this was just subtraction. And then 2x minus x gives us a single x plus 1. Now we're almost there. We have x plus 1. To get x by itself, we go ahead and subtract the 1. And in doing so, we're left with 2 is greater than or equal to x. Okay. So if you're comfortable jumping right into writing this in interval notation, feel free. But if you're unsure, draw a number line. And this is going to be a practice that helps us later in the future as well. So 2 is our important number. So let's go ahead and write a couple numbers on each side. So we've got 3 and 4. We've got this bar underneath, so that means we can actually equal to. So here we're going to have a closed-in circle. And now ultimately what this is saying is I can take all x values that are less than or equal to 2 if you rearrange this. Where basically 2 is the biggest number. So remember, the inequality points towards the biggest thing. So that means we're going to shade the left-hand side here. If you don't personally like that, or when we're dealing with something that's more complicated, what we can do is we can call the left side interval 1, the right side interval 2. And we can go ahead and pick a value from interval 1 and see if it satisfies that original equation. So if I want a number that's in interval 1, we could pick 0. So if I plug this back in at our starting value, that would give us 0 plus 3 is greater than or equal to 2 times 0 plus 1. So that gives us 3 on the left-hand side, and we're left with 0 plus 1 on the right, which gives us the inequality 3 is greater than or equal to 1. And this is a true statement, so interval 1 is what works for us. I can equal all these values here. And then if we pick something from interval 2, we can see this one doesn't work. So a number that falls in here is positive 3. So plugging that in would give us 3 plus 3 is greater than or equal to 2 times 3 plus 1. So that gives us 6 on the left-hand side. 2 times 3 is also 6 plus 1. We end up with 6 is greater than or equal to 7. So this interval does not work. So only that first interval should be shaded. So our solution, we want to express in interval notation. The solution is we start at negative infinity and we continue to 2. That is where we stop, but we can equal 2. Let's try another one. Now we're going to make it a little more complicated, and we've got that negative 3 out front. So just like we had parentheses in our equations, we're going to go ahead and distribute to get rid of them. So we distribute the negative 3. That gives us negative 3 times x. And then we get negative 3 times negative 6. And we need this to be less than 2x minus 2. So simplifying that a tiny bit gives us negative 3x plus 18 is less than 2x minus 2. And my instinct tells me I've got that negative 3x. Let's go ahead and make it positive by adding it to the other side. So that will cancel over here. That leaves us with 18 is less than 5x minus 2. Still got to isolate this value of x. So we'll go ahead and add 2 to both sides. Change that color so it looks a little nicer. So we go ahead and add 2. And this way it cancels each other out. 18 plus 2 is 20. And that leaves us with 5x on the right. And so we're almost done. We got to get rid of the 5. So we go ahead and divide by it. And since it's a positive number, I don't have to worry about flipping the sign. We end up with 4 is less than x. So again, you want to jump into writing that in interval notation, feel free. But if you need a little help, draw a picture. So we'll draw a number on each side. 4 is our important number, but I don't have that bar underneath, so that means I can't actually equal it. But I can take all values that are bigger than 4 because I'm pointing away from it. So we go ahead and shade to the right in this case. If you want to pick values, plug it back in, feel free. But ultimately, our solution is we start at 4. We cannot equal it, so we put a parenthesis. And we continue to the right forever, so we go to positive infinity. So I got one more example for you, and it's not going to be a pretty one because, of course, it's going to involve a fraction. So same thing as the equations, wipe your fractions. So thankfully, I only have one which has this negative 4 on the bottom. So what I want to do is I want to multiply both sides by negative 4. But because we have an inequality, we need to make sure that we flip the sign here because I am multiplying by a negative number. So we're taking 2x minus 5 over negative 4. We're timesing it by negative 4. And then over here, we've got 5 times negative 4. So I have to remember that this is now going to change. So ultimately, this negative 4 cancels in the denominator. We're left with 2x minus 5. Our sign has flipped. And on the right-hand side, we have 5 times negative 4, which is negative 20. So I need to get my x by itself. We've got the minus 5. Let's go ahead and add it to both sides. So those two cancel. we're left with 2x and negative 15. One last step, we go ahead and divide by 2 so it cancels, but that means we've got to divide by 2 over here as well. And so this leaves us with x is less than or equal to negative 15 over 2. This one, if you plug it into your calculator, you do get a nice decimal, but typically we want things in that fraction form. So we'll draw a nice little number line again. Negative 15 over 2, just so you can see, it is negative 7.5. So if here is negative 7, here is negative 8, 7.5 is going to be smack dab in the middle here. So I'll go ahead and leave a little mark, and there is negative 7.5. We have the bar underneath, so this means we can actually shade that value in, and we can pick all x values less than this one. So everything continues to this side. So this is why checking can also be really beneficial for you, because if you went and plugged in negative 8 and saw it didn't work, then you know you made that mistake. But of course, in time crunch situations, you might not have the ability to go back and do that. But in a testing situation, especially if you have time, check your answers.